Hi everybody. Now that you've learned a little bit about electricity and a little bit about magnetism, we are going to study what happens when electricity and magnetism get together. And in fact, the first thing we're going to look at is how electricity can cause magnetism. Electricity causes magnetism is a very simple statement. And we're going to show how that can happen. Now, that's a simple statement. We're going to make it a little bit more complicated than that. All right? So what we're going to do is we're going to follow the work of a fellow by the name of Oersted. And Oersted is responsible for coming up with Oersted's principle, which, in a sense, says that electricity causes magnetism. But he didn't quite say it so simply. Here's how he said it. He said that a current flowing through a conductor or a wire. A conductor is just a fancy word for a wire, right? So a current flowing through a conductor or a wire causes a magnetic field, just like a magnetic field around the conductor. So that means that every time you have electricity going through a wire, there's a magnetic field around it. It's almost like the wire is somehow becoming magnetic. Now we'll draw a picture here to understand what this might actually look like. So let's draw ourselves a piece of a wire. Here's a section of a wire, like this. Okay? And all I'll do is I'm just going to move this over here out of the way a little bit. Okay, good. And then we're going to just color it in a little bit gray so we can get some perspective. The magnetic field, well, let's put the current on first. Current flows from plus to minus. Remember, positive to negative. So let's put a plus down here and a minus here to show that the current in this wire is going this way. See the black line? It's going from the bottom to the top. The magnetic field then that forms around it forms like something like this, little circle shapes that are sort of going in and out of the screen. It's like a 3D picture, okay? Think of these as a bunch of little hula hoops all sort of sitting on top of this wire like it was a peg or something. And so the hula hoops are kind of, perpendicular to the screen. Now, the trick is that those red lines have to have a direction on them. And if you're a loop or a circle, there's only two ways you can go, clockwise or counterclockwise. So we have to figure out which way it is. Now, the way we do it is we do right-hand rule. That's what this is called. Right-hand rule number 1. And it's called number 1 because there's 2 more that we have to learn after this one. Right-hand rule number 1 says that if you grab this wire with your right hand, so I'm going to see what happens. Let's see if I can draw a picture of grabbing this wire. Let's draw a little finger right there, and then the finger kind of goes up and around like that. Okay, and then here's another finger, and another finger, and your baby finger grabbing that wire like that. Then what happens is if you stick out your thumb sticks out that way, and then this is the palm of your hand, and your wrist goes like that. And so these are your fingernails right here. You have to pardon my bad drawing. There's your thumbnail. And what I can do is just to help it look a little bit better, I can do a little bit of shading right here to show that these fingers are sort of in front of the wire, grabbing the front of it, you see? And the palm of the hand is kind of behind the wire. If you grab the wire like this, you'll notice something really cool. Your thumb is pointing in the direction of the current. So it's telling you which way the current is going. The electric current, right? From plus to minus. and your fingers are wrapped around the conductor. No, not fingers, fingers. Your fingers are wrapped around the conductive wire. They wrap in the direction of the magnetic field. In the direction of the magnetic field, which is the red lines. All right. So what does that mean? Well, it means that if we follow the way our fingers are wrapping, our fingers are tucking in behind over here. So these parts are going this way, and they're going around behind the wire. And then on the other side, they're coming out in front of the wire, kind of like this, and wrapping around like that. You see how our hand is a very good tool for showing us which way these red magnetic field lines are spinning or are directed around the wire. Now you see also that I've drawn one little set of circles, but those red circles would actually have to be drawn all the way up and down the entire wire, so that there's red circles going around every section of wire. But it's hard to draw that, and then I wouldn't have had room for my nice little hand. So to keep it simple, I just drew one set of circles. The magnetic field is strong in close to the wire, so we have a strong field in close to the wire, but weaker when you get out away from the wire. So the distance you are away from the wire. So let me just put some dots. If I'm right here, very strong field. But if I'm over here, the field is weaker because I'm further away from the wire. See? So here's spot 1, here's spot 2. Spot 2 is a weaker field. So we also know that. Okay, now what I'm going to do is I'm going to draw this picture in another way. I'm going to try to take the top of, right here, the top of this, and I'm going to bend it downwards, sort of like as if you were grabbing the wire. Put your hand where the blue hand is. Now turn your thumb so it points right towards you and bend the whole thing down. So it's like you're looking right down the barrel of the gun. You'd be looking right here, right down the top of this wire, right there. And all you would see is a little circular shape, right? So let me draw that. You would see a little circular shape. Let's put it here. There it is. So it's like someone bent it down and you were looking down the gun barrel, right? It's a cross section. Now it's easier to draw the magnetic field lines because if you're looking down, they're perfect circles now, and they go all around like this, right? If you're looking straight down on the peg with the hula hoops wrapped around it, that's what it would look like. Now how are we going to show the direction of the current? It's easy on this picture because we can put a plus and a minus at both ends, or we can put an arrow. But down here, all I've got is a little circle for my conductor, so I can't put an arrow, I can't really put a plus and minus. So here's what we do. The way we describe the current is it's either going to be going towards your face, out of the screen. So if it's coming out towards you, right? Or it could be going away from you and going into the computer screen. So we think about a little arrow which has a pointy tip and has feathers on the back. If the arrow is coming towards you, you'd see the pointy tip. So we put a dot right in the middle there for towards. And away, you would see the tail feathers in a sort of a cross. So the cross means something going away, and the dot means something moving towards your face, in and out of the screen. And so if I bend this down, you see the arrow that's showing which way the current is going. If I bend this down and look at the top, I would have electricity shooting out right into my face, wouldn't I? Like bullets from a gun. So this could be electricity coming towards me, so I'm going to put a dot in the middle to show the electricity is coming towards me. Now, here's the hard picture. And I'm not very good at drawing this at all, but you have to kind of point your thumb sort of straight towards you out of the board, and then your fingers wrap around this way. Okay, those are pretty wild looking fingers, but that's okay. Let's make them a little smaller. Your fingers kind of, right, and these are your knuckles back here, right? And your fingers kind of go up like that, and they wrap around sort of like something like that, and there'll be a couple fingers in there. And the wire is right here. You're grabbing the wire like that. And then your hand is coming down like that. So what's hard to draw is that this part of your thumb is actually sticking straight out of the screen towards you. Straight out of the screen. Whereas your fingers are bent over sort of that way. Right? Bent over like that. I could probably do that slightly better if I try one more time, but I think you get the idea. Let's just draw that circle again. And your fingers are kind of bent like this, right? And then this is sort of the palm of your hand. And then your thumb is right there, sort of pointing out. And then this is your wrist, like that. And these are your fingers, sort of bent like that. Here's your fingernail. And your thumb is pointing straight at your face in the same direction as the dot in the circle. And so you can see that now very clearly your fingers are curved this way, so the magnetic field would be like this. And this is exactly the same picture as the one above, except it's twisted, right? Notice how if you twist it down, these arrows right here will be sort of at the top, going right to left. There they are, right to left. And the other arrows at the bottom coming across in front would be going sort of left to right, and there they are, down here, left to right. So this picture, without the little green stuff, is another way of representing the same picture as above, except it's done in a different sort of direction. But it's harder to draw the hand, because you can't draw a thumb that sticks straight out of the board at you. Very difficult. Okay, now what I'm going to do is give you a couple of these to try it on your own, and then we'll see if we can't get you using this right-hand rule. Okay, so let's make these a little bit pin. Let's go a little thicker. Oh, I guess I can't. All right, here is a wire, and here is some magnetic field lines going around the wire. So where the space is, they're going around the back. And on this wire, there's current flowing from plus to minus. All right? You have to tell me which way those field lines should go. And I'll draw another one over here like this, and I'll draw the field this way. So the space means they're going down around the back, behind. And I'll put plus here and a minus there. So, yeah, that's good. And then I'll do two more, or one more. This time what I'm going to do is I'm going to put the current like this, and I'll put the circles. But instead of showing you the direction of the electric current, I'm going to put arrows on here to show which way these guys are actually going. Okay? So, now your job is to use your right hand, and the first two you have to put the arrows to show me which way the red magnetic field lines are going. And in the second one, I already gave you that, you got to show me which way is the electricity going in the wire. So pause the video, try and do that with your right hand rule, and when you're ready, we'll come back and I'll show you what the answers should be. So I'm assuming you paused and you're back for the answers. And let's look at this first one. What we need to do is we need to grab the wire so that our thumb points in the current direction. And it's going to look just like the picture that I started with. I want my thumb to go up like this, and I want my fingers to come around in front of this, something like that. Another finger, and so on. But the fingers have to cross the wire this way, thumb pointing up. And if that happens, you can see that what should happen here is the arrows go this way down around the back and this way out around the front. Right? So your thumb points in the direction of the current, and it's of course always positive to negative current flow, which we call conventional current. Now in this picture, it's a little bit tougher because I have to point my thumb in the direction of the current. So my thumb has to point this way. But that means that my hand is sort of going over, sort of like that, around the back. And so I have to color it in. I have to kind of, there's my color here. This part is all in front of the wire, you see? And so I have to grab it like this. So my whole hand is in front of the wire on this side, and my fingers are going around the back of the wire. Okay? That's the only way you can grab it, so that your thumb is pointing in the direction of the current. And now I can see that if that happens, you have to come up over the top like this, and then tuck down and behind like that. That would be the answer. Now for this last one, well, if I use my fingers now, I have to put my fingers the right way. I have to get my fingers to go the same way as those red arrows, which means it's kind of the same picture as I just drew up above. You're going to have to end up with your thumb going this way, and then your fingers are going to wrap around sort of behind like that, and come over the top like that. There's my fingers, there's my hand, and if I color it in again, these are on the front side, and that little tip of my fingers is on the back side. So I get something that looks like that. And there's my fingers in behind, right? In behind. And you might have another finger right there and another finger there. Okay? So that's the idea. And so it turns out that this is the same picture as the one up above, isn't it? Which means that the current must have a plus here and a minus here, and that would be the answer. It goes from right to left. Okay, so you can practice this right-hand rule with the practice sheets or the practice that I'm going to put on. I'll give you some of the original notes from the original course that have some good pictures. You can read through that. And then eventually we'll have a little bit of an assignment where you can actually try doing some on your own for handing in. And that'll be it for this video. In the next video, we'll look at right-hand rule number 2, which is a little more complicated. And we want to make sure we understand this one first before we go too far. So that'll be it for today.